Okay, good morning or hyvää huomenta in Finnish or only shortly huomenta. Today we will start this mathematics studies and in the beginning we will have some kind of refresher course. So unfortunately those who had no problems with this test, I don't have so much to give you in the beginning of this course. But I try to record all these lessons. I know beforehand already that sometimes I get some problems. These applications and equipments in these classes vary a lot, and I think now I had time to test this recording, and I hope it will go right now, but it is not 100%. But if you have not possibility to join the class, you may watch those videos later, and I will add those to the Moodle page. I yesterday had lessons for online group, and I recorded those lessons already there, and I try to go different examples during these two groups. The same mathematics, but different problems. So if you want to test your knowledge and know how to calculate some problems, you may try to watch those videos from this different group and then try to do that problem and calculate that and check from the video if it went correct. And of course you may ask help in any time, 7 days a week and 24 hours a day, but I answer only in summer. Sorry, that was a joke. But I try to answer so quickly as possible. I mostly use WhatsApp. You may send emails or WhatsApp messages. WhatsApp is, I like that more, especially when there is some small problem you have to ask help. It is quite quick to answer that. Unfortunately, I have quite a lot teachings this autumn, so especially during September and October, and I don't have so much time during working day, but I will answer in the evening then, or in the next morning. I try to answer those messages during the same day you have sent those. I will start this course, as I told, with this refreshment part, and first I will go through these problems you tried to solve on, was it Friday, I think, and you had there 20 problems which concern basic calculation rules, and then there were 6 problems concerning basic geometry or rectangular triangle. This has also, this can maybe also be called right-angled triangle. But first I will teach you some Finnish. I think I have heard that you some already know some Finnish. You have you have said me some words in Finnish already, but I sometimes here in lessons I wrote these some Finnish words which are.
Might be that some people just knows.
Yes, I think I see it here correctly, but has it done this much today?
Yes.
Oh no. Let's stop recording. Okay, let's try to continue. He told that he will quit this class quietly, so this machine doesn't notice he is calling. I don't know. There has been some problems with this cable earlier, but I hope it will work now. Yes, let's take Finnish numbers first. Nolla, zero, nolla. I think in many languages this is almost the same word. Nolla. You don't have to learn these. I only want you to get familiar with some mathematical words that you find in mathematical environment here in Seinäjoki or in some technological environment. You may see those numbers there, so you could understand, or hear some numbers. You could probably learn to understand those. Yksi is the number one. Number two, kaksi. When we count quickly, many times we say YK. YK. But these are not official words, so don't use those. Use yksi and kaksi. But when you count YK, kone, viku quickly, and I think many languages you have this shortened form of numbers. It is quickly to count. And let's take 3 here, kolme, and next time more. Then some words we had in this test. This was written in English, but some mathematical words simplify the expression. This first problem. Simplify. It is in Finnish. Sievennä. Sievennä. It comes from the word sievä. If I see, for example, or don't think about me, but maybe if someone sees a beautiful girl, he may say that she is sievä, cute, and this sievennä, it means something like that. Make this expression more cute, more nice, more beautiful, if you translate it correctly. Expression, in many problems here you see that word, expression. Expression, this is in Finnish lauseke. In Finnish, if you have some, for example, you are reading a text, I want to know, in Finnish, I want to know your current level of mathematical proficiency. This is lause, and it comes from that word lauseke. This is some kind of, actually I don't know the word in English, what is called. Yes, sentence. Yeah, yes, sentence. So lause and sentence mean the same thing. And then there was problems where you have you had to solve variable from the equation. Solve is ratkaise. Ratkaise. I probably in quite soon will add to that Moodle page some problem series there, and I don't have every time have time to translate them in English, but there may be, for example, this kind of problems, and there might read here sievennä lauseke here, so you understand what to do. Mathematical is so actually universal language, so it is not so problem if you have a material in different language, especially in these basic rules exercises. But I try to translate them so well as possible, but not every time I have time for that. And of course, I will help you translating if you don't understand what to do. And then we have this word here, hard to pronounce for me. Equation. How do you say? Equation. Yeah. In old Finnish, or actually it was not Finnish language, but if you find mathematical books over maybe 150 years old, they might read in some kind of Finnish ekvationi, solve ekvationi, and it was some kind of Finnish form of that equation word, yhtälö in Finnish, in modern Finnish. So with these words you I would say that you could understand what to do in every problem here in this text, even though it would be written in Finnish. Variable, solve variable. Muuttuja.
So how would the sentence be solved variable? It will be ratkaise muuttuja.
Yeah. Ratkaise muuttuja.
One A, not partitiivi.
No, muuttuja. One A. Muuttuja. Okay. So I will start to going through these problems here. I go them not in this order as it was in this test, but I go in some kind of order in which the easiest problems come first, and then we go to hardest one. Not in right correct order, but almost. When I checked those tests you made and also the online group made, I got I guess it was 35 tests I got back. Some tests some online students have sent via email, but I have not yet had time to check those. But little about 35 students send those answers to me. And for example, the number 1, this problem 1 here was such kind that 86% of those who made that problem find and got a right answer from that problem. I have a habit where I write T letter in front of number of exercise. It comes from Finnish. It is some kind of habit that I very easily to do. This T comes from Finnish word tehtävä. It is problem or exercise. Tehtävä. This tehtävä word, if you translate it correctly, it means something you have to do. Tehtävä. To do is tehdä, and tehtävä is something you have to do. So you have something you have to do, and in this case it is the number 1 you have to do. And there you have had this kind of sentence here or expression. And this was, as I said, made correctly by 86% of students in this first time. How do you calculate this? You have to simplify this. Well, there are many ways to do. I have a habit to use parentheses. These are Finnish called sulku. Or some use word sulje. But I for me this sulku is more familiar. Parentheses in English, if I write that correctly. And then I watched that expression there, and I see that there are B letters in everyone there, so I put B here after this parenthesis, this closing parenthesis, and then I pick those coefficients there or factors there which are in front of this letter. So there are -3, -2, +5, -3. What is here? 1. Yeah, actually -1. This point is the most common origin of error in this problem. It is always easier to see those numbers here. -3 you see there, and -2 you see there, +5 you see there, -3 you see there, but here you can't see the number, but it is -1, and then you see +7 there. Mostly if this was not calculated correctly, it had a error there that this student who had calculated this has forgotten to take this part here. But if you don't take it account in this sum, it means that this is not here at all. It would mean that the factor in front of this B letter would be 0, but there is no 0 there. It is now right now -1. And then you try to calculate this correctly. Is it 3? Do you say? Got the same. If you notice that I make errors, just tell me. It is not a shame for you, but for me. 3b. 3b. 3 is 3. In Finnish we say this letter B. Unfortunately, that camera, or does it show the colors correctly? Not really. This. I like this color more than it is shown in this paper right now. Or in paper, it is shown very nicely, but in this that camera, there's some problems with the colors. Okay, let's go next to the problem, and remember, always ask when you have something to ask. I don't necessarily want to only be in loud here in class. You may always ask or comment if you have something to say of the problem. The next one is problem 17. And in my statistics, it was calculated correctly by 74%. And this was an equation problem. Mostly students could actually solve this problem, but there came some sign errors, and that is most usual error in this kind of problem. Solve variable x from the equation. Ratkaise muuttuja x yhtälöstä. 8x minus 5 equals minus 7x plus 9. In Finnish we usually this minus and plus signs, we say it miinus, plus. We actually in Finnish we pronounce words as they are written, or at least we think we pronounce them as they are written. This sign here, equals equality sign, in Finnish we call it yhtä suuri kuin. So in Finnish I would say this 8x miinus 5 on yhtä suuri kuin miinus 7x plus 9. So, yhtä suuruusmerkki, equality sign. And how do you solve this? You have to find x from this equation. What do you do?
You get x to one side and the normal number to the other side.
Yeah, and what do you do when you do that? Just change, or
I will get minus 7x to the left side as plus 7x.
Yeah. So you have to change the sign there. Mostly, that is how mostly this has been solved and is being solved. Actually, if you make that correctly, I will write this as some kind of correct way, mathematically correct way to solve this, but this way which I write here is not even almost nobody does this actually. It is mostly solved as you said. When you have this equality sign here, it means that you have the same value in both sides of the sign. Those are same numbers here. 5 is equal to 5, but we don't know what this because we don't know the value of x. We don't know the value of this sentence or this sentence. We only know that they are equal. And if they are equal, there is no problem to add or subtract the same number from both sides of the equation. For example, here you see -5 here in the left hand side. So it is correct to +5 here and +5 here. If those were equal, they will still be equal if we add 5 to both sides. And also we may do, here we have -7x. If we want to get rid of this part of the sentence in the right hand side, we may add 7x to both sides. So if we add 7x to both sides, this is still equal, this equation. But when we do this, I will write it one intermediate stage here. We had this 8x minus 5, and then we add 5 and 7x here in the left hand side. In the right hand side we had earlier -7x plus 9, and we add 7x and 5 there. And now what happens actually, we had -5 here and we add +5 there, so these are cancelled. It becomes 0. And here we have -7x and +7x. These are also cancelled. So what we have after those cancellation, how do we say, cancelling, we have 8x plus 7x here in left hand side, and 9 and 5, plus 9 and plus 5 in the right hand side. And when we watch this equation and compare it to the first equation here, we see that what has actually happened is that this -7x has been transported to the left hand side, and the sign has been changed. It was minus here in right hand side, but now it has became plus sign in the left hand side. And the same happens with this -5. This has been transported to the right hand side, and the sign has been changed to plus. So actually, when we solve this kind of problems, we don't usually use this intermediate to this part at all. We just sum from this line to this line. But this is the reason why we can do this sign change, and why we have to do it when we solve this problem. And then we continue. Here we have 8 and 7, so totally 15x, and here in the right hand side 14. In some papers, this problem had been solved to this point, but after this there was nothing. So either student thought that it had been solved already to the end, or then she or he didn't know how to continue. What would you do after this? Divide, yeah. And which will be divided? Yeah, 15. So usually I usually put 2 lines and divide by 15. So it means that I divide this coefficient in front of x letter here in left hand side. So what happens? You get x equals 14 divided by 15. Yeah.
If you leave the equation like 15x equals 14, it counts as a wrong answer.
Yes, it has been not solved to the end. When you have this kind of problem where it is said that solve variable x, you have to get the x. What is x? And this is not ready already. I'm in some problems. Actually, this was only some kind of test, so it is not an official exam. But I may have give 0 points or 1 point or half point, 0.5 points, and mostly these 0.5 points were in problems where there were some kind of we have only two problems right now here, but some problems when you get a fraction to the answer, and it was correct fraction, but it had not been simplified to the end, and that might give that half point in that test. Sometimes in this kind of equation problems, student has calculated almost correctly, but in this last part he or she has divided in wrong way. So quite usual mistake in this kind of problem is that the answer is not this but inverse. So it is 15 divided by 14. If you are not quite sure which will be in top part and which will be in bottom part of this fraction, try to compare with easy numbers. For example, if you have easy multiplication, for example 3 times 4 equals 12, and if you compare this to this form, 15 times x equals 14, and in this our problem we have to solve x, and we have to try to find out what to do with 14 and 15 to get x. If you watch this compare easy number example, we have this 4 in the place of x, and if we think what have to be what should be done to 12 and 3 to get 4, you don't have to think very long. You find out that you have to divide 12 by 3. So this 12 will be on top part and 3 will be bottom part. So the same is true in this our equation. 14 will be in top part and 15 will be in the bottom part. Sometimes these easy simple number examples help to find out calculation rules in a situation when you don't have numbers, you only have letters there, and it is easy.
Maybe another way is the purpose is to leave x on one side,
Yeah.
so we can divide both sides by 15.
Yes.
And
Yes.
then we get the answer.
Yes. That is good. Actually, yes. I will put that also there. We had this stage here, and when we divide that by 15, that actually means that we divide both sides of the equation by 15. And if we do that, we may write 15x divided by 15 equals 14 divided by 15. This is almost the same thing as we did here. We add same numbers to the both sides of equation, and this can be also done. We may divide by the same number and still the equality sign holds. So in the left hand side here we may cancel these 15s away, so there only x stays there, and in the right hand side we got the answer to the problem. But be careful in this kind of situation. Think twice before you write the answer, because it is sad that sometimes a very big equation and you make lots of work to solve that, and then you make mistake in the last part of that. And in this situation the mistake is not so big, because 14 divided by 15 is almost same as 15 divided by 14. They are both nearly 1, but in most cases the error is very big. Okay, let's have a break in this point, 15 minutes break. I will try to save this recording so that I can put that in YouTube format in some break today.